Good morning. In this session, I am going to explain previous JEE questions given on the topic friction. So, let us move on to the problems on friction. See, a block of mass 10 kg, 40 kg slides over a surface when a mass of 4 kg is suspended through an inextensible massless string passed over a frictionless pulley as shown. Coefficient of kinetic friction, what is the acceleration? Here this is the entire system and its weight mg acts in the vertically downward direction that tries to set the system into motion. Friction comes into play whenever there is relative motion between the two surfaces of contact to oppose the motion. So, friction comes into play in this direction and the frictional force is on a horizontal surface. Frictional force is equal to mu k mg. In this case, this is coefficient of friction is given as 0.02, mass of the block is given as 40 and G is 10, G is given as 10. So, friction is 248 Newton, frictional force. External force that tries to set the system into motion is 4 into G, that is 40 Newton. We know acceleration is produced in this direction. External force minus frictional force is equal to the net force creating an acceleration A. So, here F is 40, frictional force small f is 8. This is equal to the total mass of the system is 40 plus 4, 44 into E. So, 44A is equal to 40 minus 8, 32. A is equal to 32 by 44. So, 4, 8 times, 11 times. Acceleration is 8 by 11 meter per second square, right? Next problem, look here, very interesting problem. In that system, block system, this is 8 kg and this is 2 kg. This is the interface between them is rough with coefficient of friction 0.5 and this is smooth. The surface on which that 8 kg block is placed is a smooth table, right? Find the maximum horizontal force that can be applied on this block so that the blocks move together. Blocks move together implies they are moving with the same acceleration. Now, here, if this block moves with acceleration A such that F is equal to the total mass it is supporting is 8 plus 2 into E, right? That is the, so F is equal to 10A, that is equation 1. In the next thing is between these two the frictional force sets the upper block to slide with some acceleration. See here the frictional force acting on the upper block is equal to mu mass of that block into G. So, here frictional force F creates acceleration in that block which implies mu mg is equal to ma. So, the acceleration of the upper block is mu into G. That is, from this acceleration is mu is given as 0.5, G as it is not given, we take it as 9.8. Substitute this value of acceleration here to get the applied force, maximum possible applied force. It is 10 into acceleration is mu G, 9.8. So, this is 98 into 0.5, that is 49 Newton. This is the correct option for that problem, right? Now, Look here, a steel block of mass 10 kg, this is 10 kg, is placed on a horizontal floor. 3 iron cylinders are placed. Cylinders go down with an acceleration 0.2 meter per second square. Normal reaction by the floor if mass of each cylinder is 20 kg. So, this becomes a 10 kg block and this becomes 3 cylinders of mass 20 kg each, so 60 kg. As a result, this moves down with acceleration 0.2 meter per second square. The normal reaction is how much? It is so simple, perpendicular to the contact surface, frictional component is 0. Frictional force is always tangential, so its component along the normal reaction is 0. Hence, here this is unnecessary data given because there is no contribution of friction to the normal reaction. We know here normal reaction is total mass into G minus A because this surface is going down with an acceleration A. So, mass is 10 plus 60. This is 70 into 10 minus acceleration is given as 0.2. This is 70, 10 minus 0.2 is 9.8 or 7 into 98. So, 7 into 98, right, because 70 into 9.8 or 7 into 98. 7 8s are 56, 686 Newton. This is the correct choice for that problem, right? Now, next problem. Look here, a block of mass slides along the floor when the force F is applied at an angle theta, coefficient of friction is mu k. What is the acceleration? Look, here this is a block placed on a rough horizontal surface. Weight mg acts downwards. A force F is applied, a pulling force F is applied at an angle theta with the horizontal. Its component along the horizontal is F cos theta, its component along the vertical is F sin theta. So, as a result, the normal reaction here created is mg minus F sin theta. The possible friction is mu into normal reaction mu of mg minus F sin theta. It opposes the motion, it will be like this. So, here if you draw that F cos theta acts in this direction, frictional force acts in this direction, acceleration is produced in the direction of applied force. So, ma is equal to F cos theta minus frictional force. Frictional force is mu k of mg minus F sin theta. So, acceleration is, if you bring this to this side, F by m cos theta minus mu k, whole thing divided by mass, m and m gets cancelled, g minus F by m sin theta. This is the acceleration produced. Look at the option, F by m cos theta minus mu k, g minus, this is the answer. Okay? So, that is the right choice. So, when pulling force is applied, if F cos theta is the external force tries to move the body along the horizontal, frictional force opposes the motion. F cos theta minus friction is mu k of mg minus F sin theta, that is equal to ma. F cos theta minus mu k of mg minus sin theta is ma. Okay? Now, next problem. Look here. A given object takes n times to slide down a rough incline when compared to the time taken by it when it is perfectly smooth. Find the coefficient of friction. Look here, I am explaining you the problem. Suppose if this is a rough surface, if this is a rough surface, the time taken by it to slide down the incline t is equal to square root of 2L by g sin theta minus mu cos theta. That is taken as T1 psi. If the same surface is smooth, mu becomes 0, time taken will be square root of 2L by g sin theta. In this problem, he mentioned that when the surface is rough, it takes n times time taken by the same block to slide down the same incline when it is smooth. That is, T1 by T2 is given as n, implies n is equal to T1 by T2, that is sin theta by sin theta minus mu cos theta, because 2L by G gets cancelled. So, squaring on both sides, n square is equal to sin theta by sin theta minus mu cos theta. What do you want to find here? Coefficient of friction. So, to find coefficient of friction, look here, sin theta minus mu cos theta is equal to sin theta by n square. So, 1 by n square is equal to, bring this sin theta to this, sin theta by sin theta is 1 minus mu by tan theta. Sin theta by cos theta is tan theta. We want to find out mu here. So, if you bring this to this side, mu by tan theta, look, mu by tan theta is 1 minus 1 by n square, or mu is equal to tan theta into 1 minus 1 by n square, or mu k is equal to tan theta into 1 minus 1 by n square. So, here n is when the body is sliding down a rough incline, it takes the time n times that taken by the body to slide down the same incline if it is smooth. Okay? Now, so which is the correct option? What is given here are asked mu k. So, mu k is equal to tan theta into 1 minus 1 by n square, as theta is given as 45, mu k is equal to 1 minus 1 by n square. This is the correct option. Go to 6th problem. Look here. A block of 5 kg is placed, coefficient of friction is given, F1 is the force required to just move the block up the incline, F2 is the force required to just prevent the block from sliding down. See here, I am telling you a secret. So, I am going to tell you 3 very important points here. See here, this is a rough inclined plane of angle theta, coefficient of friction mu, and a block of mass m is placed. So, the minimum force required to just prevent it from sliding, down is minimum force is F is equal to mg of sin theta minus mu cos theta. You know it already, isn't it? Now, look here, maximum force to prevent it from sliding down is F is equal to mg into mu cos theta minus sin theta. to just prevent it from sliding, maximum force is. And the third one is minimum force required to slide it up the plane. Up the plane is mg of sin theta plus mu cos theta. You have to be very, very careful about these three. Now, do you remember? So, I told you, I am telling you a secret which is very important in friction. So, the first one, minimum force required to prevent a body from sliding down the incline is mg of sin theta minus mu cos theta. Maximum force that can be applied to prevent sliding down the incline is mg of mu cos theta minus sin theta. That's all. What is the minimum force required to just pull it up the plane? Mg of sin theta plus mu cos theta. Now, have all those things in your hand. Now, look at the problem. F1 is the force required to just move the block up the plane. So, minimum force required to just move the block up the plane is mg of sin theta, this one, sin theta plus mu cos theta. And F2 is the force required to just prevent it from sliding down. This is the minimum force required to just prevent it from sliding down. Mg of sin, is it minimum or maximum given? So, F2 is the force required to just prevent the block from sliding down, that is mg of sin theta minus mu cos theta, that is the magnitude. So, modulus of F1 minus modulus of F2 will be, if you take that mg as common factor, sin theta minus sin theta gets cancelled, mu cos theta minus of minus becomes 2 mu cos theta. So, the difference between those two forces magnitude is that much. Now, you substitute those values. What is the value of m given? It is 5. What is g given? It is 10 of 2. What is coefficient of friction given? Coefficient of friction 0.1. Here it is given. Coefficient of friction is 0.1. Cos theta, theta is a root 3 by 2, right? So, 0.1 into 10, it is 10, 5 2 is 10, a root 3 by 2. Or this is, it gets cancelled 5 times. The difference between those two forces, F1 minus F2 is equal to 5 root 3 Newton. So, 5 root 3 Newton. What is, oh, actually there is a correction in this problem. I forgot to tell you before. In the original question, the option is given as 5 root 3, but here there is a printing mistake. Okay? So, I forgot to tell you in advance. So, the exact answer for that is 5 root 3 Newton. Now, go to the next problem. Look here. A block of mass m is placed on a surface having vertical cross section y is equal to x square by 4. Y is equal to x square by 4. Coefficient of friction is given as 0.5. The maximum height above the ground at which the body can be placed without slipping. See, look here, y is x square by 4, the surface will be like this. That will be a curved surface very obviously. Let us assume the object goes to that maximum height from this point. When it is at this point, mg will be acting in the downward direction. Let this be theta. So, its component along this is mg cos theta. So normal reaction R is equal to mg cos theta, and this component, its component along this is mg sin theta, because of which the body slides down. Look here, the possible friction that comes into play is mu into normal reaction, that is mu mg cos theta. This acts in this direction. So here the block can go to that maximum height, or the block doesn't slide if friction could balance mg sin theta. So that F must be greater than or at least equal to, possible friction must at least be greater than or equal to mg sin theta, and F is mu of mg cos theta, that is greater than or equal to mg sin theta, from which mu is greater than or equal to tan theta. Okay, tan theta is nothing but dy by dx slope. So y is equal to x square by 4, tan theta is dy by dx. So dy by dx from this is x square derivative is 2x by 4, this is x by 2. So from this expression, mu must be greater than or equal to x by 2, right, x by 2. So from that y is equal to, what is asked, the maximum height at which the block can be placed without slipping. So y is equal to x square by 4. So here from this what can we say? Mu is greater than or equal to x by 2, or x is less than or equal to 2 mu, or x is less than or equal to 2 into mu is given as 0.5. So x is less than or equal to, x is less than or equal to 1, 2.5s are 1. Now substitute that in this expression. So maximum possible height is taken as h, that is equal to maximum possible value for x, that is 1 x square by 4, or h is equal to 1 by 4 meters. That's a beautiful problem, isn't it? Actually here we have done the same model in another class. When an insect is crawling in a bowl, if mu is the coefficient of friction, the maximum angle up to which it can